Okay, y equals 2 to the x is your basic exponential function, okay? And instead of basic, I really wanted to say base 2. Okay? I consider it basic, so I wrote basic, but I really wanted to say base 2. Okay?
Okay.
Because it's really easy to understand, and it's really easy to understand doubling times and half-lives and so forth. Okay. Easily make a table, and we've done this. Okay? We understand how we get 1/4. Okay? 2 to the negative 2 equals 1 over 2 squared, which is 1/4, for example. Right?
Right.
Okay? And I wrote 0 here, which is really ignorant. Okay? My students do this, but that's not why I did it. I just had these numbers in my pattern. And of course, 2 to the 0 equals 1, right? Because any number to the 0 power is 1. Okay? So we have that, so we easily get our graph. So we put 2 here, we put negative 2 here, we put 1 here, we put negative 1 here, and we'll put 1 here. Okay? So this is where y equals 1. So y equals 4 is going to be twice that high and twice that high. So y equals 4 here. Okay. Now, at negative 1, we have 1/2. At negative 2, we have 1/4. Half as high here as it is here, and twice as high here as it is here, right? Because every one of these gets twice as big, doesn't it?
I do.
Okay? And at 1, we get 2. And at 2, we get 4. So we get a graph that looks like this. Okay?
Okay.
And here, we keep doubling the value of y with every additional unit of x, right?
Right.
So it gets very steep very fast. We're going to get twice this high. It's going to be way up here if we just go over to x equals 3. It's going to go twice that high, and I can't reach that high, I can't jump that high. Maybe there was a day when I could, but not now. Okay? And you double that, and LeBron James can't jump that high. Okay? Actually, maybe he can, but you double it again, nobody can jump that high. Okay? So, it keeps doubling, it keeps halving when we go this way. Keep cutting it in half, which means it gets twice as close to the axis, then twice as close, then twice as close. And after a few more of those, it gets so close nobody can even see how far it is from the axis, it's so close. Okay, it gets down to the subatomic level after a few dozen halvings, okay? So, as a result, we approach the x-axis as an asymptote, okay? So that's your 2 to the x function. Now, if it was 3 to the x, it would still be 1 here, because 3 to the 0 is 1, right?
Right.
But then you would triple the height every time, so it would go up even faster, right?
Right.
And you would cut it in third every time, so it's going to approach the axis here much faster. Okay?
Okay.
Now, the 2 to the x and 3 to the x are worth understanding, and it's worth graphing the 3 to the x as well as the 2 to the x on the same set of axes. Because we get this very important number, e, which is between 2 and 3. But it's closer to 3. It's 2.718281828, but it doesn't repeat after that. Okay?
Okay.
So, we'll see what good that is, and maybe we'll see why. But I want to give you just really good overview. Now, an inverse function Okay, if we want to make a table, we just switch the columns. It's the easiest way to understand the inverse function, and your book does this. So yeah, I like the way your book does it, okay?
Okay.
So they'll be very happy to know that. You tell them, it'll make their day.
All right.
Well, maybe not, maybe they don't care what I think. Why should they? Okay. So here's a table for the inverse function. You see that I've just switched the columns, right?
Okay, yeah.
Now, having done that, I can graph the inverse function. Okay, I've got to go down to negative 2 here when x equals 1/4. Now, see, here's 1. Okay?
Mm-hmm.
Now I'm going to cut the interval from 0 to 1 in half to get 1/2, right?
Okay.
So here's 1/2. And here's 1/4, right?
Mm-hmm.
Now, when x is 1/4, y is negative 2, right?
Right.
So we're just switching the x and y values. Now we'll see kind of what that does, but we'll come down here to negative 2. Let's see, we have 2 about there, negative 2. So 1/4 negative 2 is going to be about here, isn't it?
Yeah.
And 1/2 negative 1, well, there's negative 1. 1/2 negative 1 is going to be about here. Now, I do recommend that you do this. Draw it out yourself, because it'll help you understand things that you might not otherwise understand, okay?
Okay.
And then we have 1, 0, and then we have 2, 1. Okay, there's 2, there's 1. And then we have 4, 2. So we're going to have to extend the x-axis out far enough to find 4. So there's 2, twice that would be 4 about here. And that gets us all the way up to y equals 2. Okay? And then we draw a curve through this. Kind of missed that one, but you get the idea. Okay? Looks like I missed that one too. I'm not getting. Must have woke up bad this morning or something. Okay. Okay, does that make sense?
Mm-hmm. It does.
Now, one thing that we can note here, and you've seen this because you've had most of the MTEs, if I draw the y equals x line, and then the point 0, whoops, sorry, the point 1, 2, I don't know where I got 0, okay? Corresponds to 2, 1 when I reverse coordinates, right?
Okay.
So here's my 2, 1, right? So here's the point 1, 2, here's the point 2, 1.
Okay.
Okay? If this is drawn accurately, and I haven't drawn it quite accurately, the y equals x line where y and x are equal, so this makes a 45-degree angle with the x-axis. I probably should have drawn it a little steeper, it would have worked better too. But you get the idea, okay? This line lies exactly halfway between these points, and the line segment that connects these points makes a right angle with this line, okay? That's because that's what happens when you reverse coordinates. And every point with reverse coordinates is going to do that, so the same thing's going to happen here, and the same thing is going to happen here, and here, and here. Your book will show you that. It'll look good, but you should be able to construct that yourself and convince yourself that it's really true.
Okay.
Now we can do some algebra and show that it has to be true. I'm not going to show you that. We'll see what your teacher in your actual course does, okay?
Okay.
It's something I might put in my final.
No.
You probably won't have it in yours. My students probably don't want me to put it in mine either, but I might. Okay. So there's a picture. Now, why is this important? Because when we got this inverse function, this is log base 2 of x. Okay? So, there's your base 2 log function. Okay?
Okay.
So that's what the log function is. Now it's got a lot of properties, and there are other log functions. Okay? Now I'm just going to sketch this, and it's probably not going to be a very good sketch, but you should be able to get the idea. So let's just say this is your base 2 log function, or base 2 exponential function. Okay? Then y equals 3 to the x is going to do what I said before. It's going to be like this. Okay? Now, e, and you really kind of have to understand compound interest to get the simplest explanation of why e is what it is. So I'll tell you about that in a little while, but I'm not going to tell you right now. I'm just going to say that e is approximately equal to 2.718. So it's about 2.7. Okay?
All right.
It's an irrational number, so there's no end to it and no repetition. Okay? But you would expect that y equals e to the x, since e is between 2 and 3, and I didn't write the x there, okay? Since this number is between 2 and 3, you expect that this graph is between this one and this one, right?
Right.
That's not hard to understand, so and, you know, I said e is approximately that, and I'm talking about e to the x. And I don't know why I put the x on there, except I unfortunately characteristically lost track of what I was saying. E is about this, so e to the x is here, and that's approximately 2.718 to the x. Has to be between 2 to the x and 3 to the x. Okay?
Okay.
So I labeled y equals 2 to the x up there, and now I've got this in the way. I'll repeat the labeling over here. There's your y equals 2 to the x. Here's your y equals 3 to the x. Okay? Now go ahead and erase this, because if you look at it later, it might be confusing to have it down there twice. Okay? Make sense? Okay, so there's your y equals e to the x. Now the logs, well, I hope this comes out kind of okay. This is y equals log base 2 of x. You just reverse the coordinates like we did, and you understand why the graphs look like they do. And you can draw a more careful graph. Again, I recommend that you do. Y equals 3 to the x. If you reverse that one, it's going to look, and that wasn't very good because it's kind of, still, we'll go with it. Okay? So these are actually too close together. They should be separated kind of like that. But we have y equals log base 3 of x. And y equals log base e of x.